Hello, everyone. Welcome to today's review of Shiny. So, Shiny is a R package that allows you to turn your analysis into interactive web applications in R. And let's dive straight into its architecture to understand how it works. So, basically, we have a client and server here, which are the two components that work with Shiny. The client has a user interface through which it can enter some data. Client and server both are written in R, and the server basically has instructions to do something with the data and then produce an output out of it. Now, one would ask, why do we use web applications for something like data analysis? So let me explain that with an example of iris clustering. Now, the output of the iris clustering would be a scatter plot, and it would be a fixed scatter plot even if we want to make changes to the input data given to it. So rather than keeping on making changes to the code over and over again to change some parameters, we can directly do it with the help of the UI that we provided through the web application. So let's just understand the template of how Shiny works. As at the very basics of it, we have a Shiny library that we need to have. After that, we have a UI object that is basically given a fluid page. This is an HTML function that gives us a blank document, and every component of the fluid page would be visible to us. The server object is created using the function method that has two parameters, input and output. There are additional parameters that are used with respect to the use case and with respect to the options that we have. Finally, we run the Shiny app with the help of the last statement that we have here, where we assign UI and server. So as we can see here, if we add a hello world text to the fluid page, to the blank HTML page, it would just render a static page that would display the hello world text on it. So we obviously would love to build something more than that, that's a static web page. So let's focus on the inputs and outputs. These are the different kind of inputs we can give to the UI. We have checkboxes for single or multiple options. We have radio buttons for a single option. We have date ranges. We have file inputs and much more, depending on how we want to provide input to the server. Let's try to understand one of these components by taking example of a slider input. As we can see, the slider input that we've given to the UI page produces a result on the right, where we can play with the variables, the numbers, and work on it. So the first parameter that goes into the slider input is an input ID. This is a character string which is supposed to be unique so that we can use it to refer wherever else we can in order to work on it. The other thing is called as the label, which is the second parameter, and this helps us to decide what we need to do with the data. And third parameter is input specific, which like in this case is the range between 1 to 100 and a value on which we initialize the slider input at. Like inputs, we also have the output functions. These are the multiple ways in which we can display our output, and we would encourage you to play around some of this in order to achieve results. So in order for the output functions to work, we have to have the type of output function, and then we add output to it with the name that we want to. As we can see in this example in our UI, from where we are creating our blank HTML page, there's a plot output function with a hist name given to it. The plot is because we want the output should be in plot format, and the hist is the specific name that's been given to the output. What happens is that since it's one of the components that's in the UI, the output adds a space in the UI for an R object. But the way it works, the way we want to work with the data is displayed in the server, and we have to build the logic there. So here we will build the logic that would help us to output data in the way we want. The first step is to create an object with the output variable dollar that's appended to it, and then the name to which we want the output to be. Next is to write the logic for which we want this, and that's written using the render plot method, which is obviously specific to each and every type of output that we want to have. So in this case, we render the plot. We've written a logic that we want a histogram, and the final thing is that the way we have the output with a specific ID associated with it, we could also reference an input ID, which we had seen before was a num ID. And this is how output and input IDs are referenced throughout the code for us to run. While this was an overview, a basic overview of how a basic Shiny application would run, Shivani would now like to show how provide a demo with respect to how it actually works.
Thank you, Suraj. Okay, so now that we have a brief overview of Shiny, let us now turn our attention to a simple demonstration of an application. Okay, so the app that we, here's a screenshot of what we expect to see in the UI. Here we are trying to build a baby names trends app. And the components that we require to be present in the UI are a drop-down option here on the left, followed by a pane on the right, which has two tabs here. One that displays the table with all the data filtered by the name, and a tab for the plot that will display the trend over time. Now, what I mean by trend over time is basically the count of number of babies that were given that name over the years. Right. Okay. So let us turn our attention to some R code here. So all the elements, like Suraj described earlier, that we would like to see in the UI can be added to the Fluid page. And what the server does is basically it'll assemble all the inputs into the outputs. Now, starting from the title, here we can specify the title using a title panel function. Now, we can also give some HTML tags. There are many HTML tags that are compatible with Shiny. Here, I have just taken an example of H3, and I've given a subtitle here. Like I showed earlier in the layout, we would like to see a panel on the left and the main panel on the right. The main panel should ideally have the output, and the panel on the left should have the input. Now, I will be specifying that using the sidebar layout. Now, the sidebar layout is basically like a wrapper function in which you can call other wrapper functions to include your UI elements. So in this, the sidebar panel basically creates the panel on the left, and it allows you to create a drop-down option. Now, this is just one form of input that can be given. There are many other ways you can give the input. Here, I have chosen to provide, to select a name from the drop-down option. Another way of doing it is providing a text box where you can enter the name and then filter out your data set by that name. Now the output panel that appears on the right of the screen is the main panel. Now in the main panel, since I would like to see two tabs, the first tab should basically contain the plot, like I mentioned earlier, and followed by the table. So the tab set panel wrapper allows you to achieve this functionality. Now here, if you notice, I have used some plotly functions and DT. So plotly is basically an R library that allows you to make interactive publication quality graphs. And DT here is a package that provides an interface to the JavaScript library. The R data objects like matrices and data frames can be displayed as tables on HTML pages, and data tables, here DT, will provide functionalities like filtering through the table, sorting, and many other features, many other interactive features. So basically, these two libraries are used to provide interactive features in your UI, because in the end, you don't want just to see a static output. You would like to play around with whatever options are available in the UI. Now, moving on to the server code. Here, first, based on the input that we provide here, which is the name that we select from the dropdown, we would like to filter out all the data which is achieved using this dplyr function. And then what we do is we plot a histogram showing the distribution of the count of baby names over the years. Now, so the next important component that we will be taking a look at here is reactive. So let's say we have certain expressions in the server code that need to be used in every function. We will make sure that we compute it just once instead of computing the same expression multiple times. Like, for example, let's say I am building a Shiny web app to display the details about the BMI information. Then in that case, to calculate the BMI, I will have some mathematical formula. So in order to, and so if I were to filter out the BMI from the data set, or if I would like to perform anything in addition after calculating the BMI, in such a case, I would be repeatedly calculating or repeatedly running the same, executing the same expression over and over again. So in order to avoid that, we use something called reactive. Now here in this example, our expression is not very complicated. Here we are just filtering the name. It's just a variable. For this particular example, if I were to use input name here, where I'm filtering, like say input $name here, followed by here where I am displaying the interactive table. Here, it wouldn't make much difference like it would in other cases, like I explained. But as an example, I have used reactive here. And here you can, the wrapper name is also called reactive. And you can specify the name of the input. Okay. So now that we have understood the R code, let us take a look at the Shiny app. Now here are the here's the drop-down option that I was talking about. You can I have filtered out 50 names from the data set. So the baby names data set is quite large, and there would be a lot of names in this option, which would not be very attractive in the UI. So I have filtered out 50 top 50 names and provided them in the UI. And followed by the two tabs here on the right, like I described earlier, one tab showing the plot, and followed by the other tab showing the table. Now, the table comes with many interactive options where you can sort by the year, followed by the sex and the name. And here we have the count of number of babies in that year who were named Bria, followed by the proportion. Okay, so that's the end of my demonstration on Shiny.